Hello everyone, welcome back to Physics Friday. Thank you guys so much for all the awesome feedback you're continuously giving me. I do want to announce that I will be posting all these videos that I'm posting to Facebook. I will be posting them also to YouTube. So I'll leave a link to my YouTube channel in this post as well. And this is going to make it easier for you to revisit an old video or an old topic. You can just find all the videos in one place rather than trying to scroll through my feed on my Facebook. It'll make it easier for you guys in the future if you want to show it to your friends or your family or just revisit it, like I said. So today's topic is general relativity and special relativity. So in 1687, Isaac Newton gave us a formula for the strength of gravity, but he never explained how gravity exerts its pull, right? And he claimed in his own writing that this was a critical question that needed to be answered, but he couldn't figure it out. He said he would leave it to the consideration of the reader. In 1905, Einstein publishes Special Relativity. Think of special relativity like this. You and your friend are both at a train station, and your friend goes to board the train. They pull out a rubber ball, and they start bouncing it up and down. Now, once the train starts moving, you and your friend are both going to disagree about the path you see the ball take. What does that mean? Well, your friend is moving at a constant velocity with the ball and the train, and so when they bounce it up and down, they're going to see the ball bounce in a straight line up and down because they're all moving at the same rate. But you are not moving at that constant velocity. You're standing on the platform stationary. So you're looking at your friend bouncing the ball up and down, so you're going to see the ball travel a v path because the train is moving. Now the key equation to remember here is distance equals rate times time. Now you and your friend have seen the ball travel two different distances in the same amount of time, which means you've actually seen the ball travel two different speeds. Now imagine the same scenario, but with a beam of light traveling between two mirrors and not a rubber ball. Your friend and you are both going to see the same distances that you saw previously. You're going to see the v path, whereas your friend will see the up and down path. But Einstein says that the speed of light is constant in vacuum no matter what. So you cannot disagree on the speed. The speed between the speed of light must be constant from both references, which means that the time that it takes must be different because that's the only other variable left in the equation. So since the speed of light must be the same, that must mean that time and distance must change. Now when time changes, it's called time dilation, and when distance changes, it's called length contraction. And this is the theory of special relativity. But there's a problem with special relativity in which it only applies for objects at a constant motion. But what about an object that is accelerating? So in 1907, Einstein was thinking about a problem inherited from Newton in which he had two formulas for mass, even though they were the same. The first is gravitational mass, which is how much an object weighs in a gravitational field. And the other is inertial mass, which is how much force it takes to accelerate that object. So Einstein wants to unify these two theories, and he has what he calls the happiest thought of his life, where he imagines a person free falling in space. Now, because the object is free falling, they would not feel their own weight. But if that person was in an elevator that is accelerating, they would now feel their own weight because the elevator is accelerating. If he pulled out a rubber ball, it would drop to the floor. Similarly, if the elevator was stationary on Earth, the rubber ball would drop to the floor because of the force of gravity. So Einstein realizes that these two forces, the force due to acceleration and the force due to gravity, are equivalent, and he calls this the principle of equivalence. So Albert Einstein combines all these ideas in his 1915 paper, The Theory of General Relativity, in which he states that gravity comes from warps and curves in the fabric of space. So the sun creates a valley, sort of, similarly to a bowling ball on a trampoline, where if you put a bowling ball on a trampoline, it will create a valley, right? And the bigger the bowling ball, the bigger the valley. So the sun warps the space around it, and the orbiting bodies, the planets, the asteroids, the comets, all orbit within that valley, following that curvature. So thank you guys so much for watching. Hopefully you enjoyed it. If you did, feel free to leave a like and also comment below any feedback that you might have on these videos, any questions about relativity that you have. And I hope you guys have an awesome weekend. All right, take care.